We are solving exercise 1.28. At a road junction, accidents occur at a rate of 2 per week on average, following a Poisson distribution. Recognizing that the previous frequency is intolerable for the General Directorate of Traffic, it has decided to install a traffic light at the intersection. To analyze its effectiveness, the number of accidents that occurred in the 4 weeks following its installation is analyzed. If the number is small, less than or equal to a threshold k, it will be concluded that the semaphore has been effective. If we want to have at most a 5% probability of making a mistake in the decision, which value the threshold k should have?
To solve this problem, we had to use the statistics, because this problem isn't about something certain, it's about chance and random events. The number of accidents is unpredictable, and we use the Poisson distribution to model this randomness. The main challenge is deciding if the traffic light really worked, or if the low number of accidents was just good luck. To make this decision reliably, we can't just guess. The problem asks us to limit the chance of being wrong to at most 5%. Statistics is the only tool that allows us to calculate this specific risk and find the threshold. It gives us a solid objective way to make a decision based on the data instead of simply making a subjective choice.
The first thing we have to do is describe the random variable. In this case, it is the number of accidents that occurred in 4 weeks. As the exercise tells us, it follows a Poisson distribution with parameter lambda. In order to find this parameter, we have to assume that the number of accidents that occur from a week to other are independent. And now we can do a rule of 3. If 2 accidents happen on average during a week, how many accidents will occur in 4 weeks? Doing that, we get that x is equal to 8, and this will be the parameter lambda. We know that in Poisson distributions, the expected value and the variance is equal to lambda, so in this case equal to 8. In the exercise, they tell us that they want to have at most a 5% probability of making a mistake in this decision, but we first need to understand what does this mistake really means. So, in this case, the mistake will be assuming that the traffic light has reduced the number of accidents when in the real world it has not been reduced, and the opposite as well. So we need to differentiate what is happening in the real world to what we are assuming in the exercise. As we can see, even though that the probability of making a mistake is low, there is still a probability of being wrong. So if in reality the traffic light didn't help, then this conclusion will be our mistake. So now we need to calculate the value of k. Specifically, we want the probability that x is lower or equal to k being lower or equal to 5%, which is the probability of making a mistake in this decision. However, we cannot directly calculate the value of k that is being asked, as using our commander we can only calculate the quantile of the probability of x being lower or equal to k being higher or equal to 5%. So we will do that, and then we will show how we can use this result to obtain what the question is asking. So we would go to our commander, to Poisson distributions, to quantiles, and we obtain that the value of k for which x is lower or equal and is higher or equal to 5% is 4. So the probability of x being lower or equal to 4 is higher or equal to 5%. Therefore, we know that the next smallest value for which the probability of x is lower or equal to k and is lower or equal to 5% will be 3.
We can conclude that if in 4 weeks less or equal than 3 accidents have been observed, the traffic light has been effective. Of course, we need to consider what we have explained of the mistake, that this is what our model is assuming and what the result is obtaining. but in real world it might not be the same, as we are making many assumptions on this model. So in reality, maybe the traffic light has not been effective, but in this case, we assume that it has been effective, as the probability of x being lower or equal to 3 is lower or equal to 5%.